So we have two learning goals today, and the first one is what we're working with right here. I can match, we actually have one, why do I think you have two? I can match simple graphs with situations. Oh, we do have two. I can match simple graphs with situations. That's what you're doing right here. You match the graph with a situation. And you have to do it based on, like what's happening in that graph that matches what's happening in the sentence. So number one, the car's speed remains constant. Anybody want to offer up which graph you think shows car speed? Now, first of all, I do need to point out, before we even answer these, I want to point out that we always need to pay attention to what is on the axes, what's being represented. So as we go across the graph, on all of these, time is being represented. As we go up the graph, or down, speed is being represented, how fast, okay? So we have to keep that in mind also when we're doing these. So the car's speed remains constant. Which one do you think matches that one? C. C, okay, so graph C, the car's speed is not changing as we go across the graph. The time is going on, it's increasing, but the speed is staying the same, so that would probably be a good match for it. Okay, how about number 2? The car's speed increases slowly, but steadily.
D.
That's your graph D, okay? So down here, as we go across the graph, time is going on, and the line is going up, and it's going up at a steady pace, and it's going up not so fast, so that it does appear that it is increasing slowly but steadily, so I think I could agree with that. How about number 3? Talia, which one do you think shows the car's speed increases sharply? Graph A. So in other words, to increase this, for it to increase, it has to go up, and it's going up quite rapidly. So we would say graph A looks like a good representation for it. How about number 4? What number 4? What do you think, Maisie? Which one do you have matching number 4?
B.
Pardon?
B.
B. Graph B says, or the sentence says, the car's speed decreases gradually. So that means our line better be going down because the speed needs to go down as time goes on, and it's not going down very fast, so we could say gradually. Well, by process of elimination, it appears then that 5 should be what? E, but let's verify that it does really match. The car's speed decreases suddenly. Decreases tells us it needs to do what?
Stop really quick.
No, decreases does not tell us it needs to stop quick. It needs to do what? It needs to go down. The speed's going down. Decreases means goes down. Suddenly means what? It's dropping pretty fast. It's going to, yeah, that's the suddenly part. The decreases is, that part's just saying it better be going down. The suddenly tell you how fast it needs to happen. Suddenly, so that's why it's such a steep going down there. So it does match graph E. Okay, explain how the car for graph 2 and car in problem 2. So this is our car up here up in problem 2. The car's speed increases slowly but steadily. So right now we're talking about this one. Increases slowly but steadily. Would be different if the car started from a complete stop. So in other words, it was stopped. What would its speed be if it was stopped? 0. Okay, so how would that graph be different then? What would that look like? Anybody want to come up here and draw what they think it would look like? So we got speed here and time. Anybody want to offer up what they think it would do? We're doing problem number 6 right now. Anybody want to offer up what would that look like? Car started from a complete stop. So in other words, the only thing that's changing is it's starting from a complete stop, but they didn't say anything about its speed changing or anything like that. It just says, so it still has a speed that increases slowly but steadily. No volunteers? Come up and get your finger to magically write on the board. Okay, well, if it starts from a complete stop, where should this line start at? At the bottom, which is the origin, at the corner here, right? It should start here. And then if it's going to increase slowly but steadily, it's still going to go at that pace, but it's just going to be starting at a different location. So its speed was 0 this is what we call the origin right here, 0, 0. So let's put it would start at the origin. And you can have this picture on your notes like I have right there. That's not going to hurt anything. It's good for us to be able, because you're going to have to be able to draw graphs. That's what our second goal is. Okay. Discuss what it means for the graph of the car's speed to be a horizontal line. Do we have any of those up there in those graphs, 1 through 5, or A through E? Horizontal this way, yeah.
Okay, yeah, C.
C. So for it to be a constant speed, for the car's speed to be a horizontal line, it would have to be a what? I just said it. Constant, because remember which graph we have that our horizontal line one is C, and remember C matched with, you said this one, the car's speed remains constant. So if the line is going to be horizontal, it better be a constant speed. Not changing. Horizontal line means that what's happening on the horizontal is moving along, but nothing's happening up or down. Okay, any questions on our first learning goal, being able to match simple graphs with situations? Okay, then we're going to go to the back side of this. We're not done. We're going to use the back as a piece of paper, and we're going to turn in our books to page 164. That's where you should be already. So I want you to put at the top of this that we are going to do check it out. Page 164, let's identify where these notes came from. What are we doing? And we're going to do the only check it out problem that's on there, number 1. But before we do that, I want you to read through the example 1 that they give us, where the air temperature is constant. And I want you to read through that, look at what they did. So read through example 1, not check it out 1, example 1. Okay, now we're going to do number 1 below. The air temperature increased steadily for several hours and then remained constant. You know what? We're going to write down some of those words that should help us pick a good graph. The air temperature increased steadily. Let's write that down. Increased steadily. That's the first thing that happens. It increased steadily. So let's have a representation of what that would look like. It has to do what? Holly, it has to go up. Should it go straight up, or should it go curved up, or should it go at it says steadily, so should it go up at like a line instead of curve? Which one, Holly? The line, yeah. So let's just show that. We increase steadily. That's what that should look like. And it says that was for several hours, so that would be for a while, right? And then remained constant. Remained constant next. happens when something remains constant? What's that look like on a graph? That's the horizontal part, isn't it? Okay. At the end of the day, the temperature increased slightly again. Increased slightly. So, do you think it's going to increase as fast as that first one did? It says slightly this time? What do you think? Or does it say steadily? Oh, well then how are we going to draw what we think would happen on the graph for this one? Increased slightly, again, before dropping sharply. So, maybe we could just put both of them down here and then we'll decide what would those look like. Drop. Dropping, not dropped, dropping sharply. So they don't use the word steadily. Now we might want to rule out a line. We want to take into account maybe a curve. So what we're supposed to do is match. So maybe if we can't decide what that would look like, maybe we could go up and start matching to the graphs. Okay, so the first part of our graph has to do what?
Increase.
It has to increase steadily. So in graph A, is that what's happening in the first part of the graph?
No.
No, everybody see what the graphs are that I'm referring to in example 1? Okay. How about graph B? Is that one increasing steadily at the beginning? It's pretty flat, isn't it? Okay, how about graph C?
Yes.
Does that look like an increase steadily? It's going up and it's a line, okay? Our second thing that's supposed to happen, so now we're going to stick with graph C. Our second thing that's supposed to happen is it's supposed to remain constant. We said that should be horizontal. Is that matching on this? Yeah, it is, isn't it? Okay, well then it kind of goes like this. Let's do this. Kind of goes like that. Next. So that's, is it increasing? Is it increasing in this little? No. Is it increasing steadily? No, because it's not a line. And remember, it didn't say steadily, it said slightly. So I guess that's their way of showing increasing slightly. And then our last one is dropping sharply. Well, on a graph, it's doing this, isn't it? Right? So does that, is it dropping? And is it pretty sharp? It's probably even sharper on there than I made it on mine. I'll make it, a little bit sharper. So when we put all of that together, we would say that we do agree that it would be graph C. And I want you to recreate that graph on your notes here. Okay, don't be taking up the whole paper here, by the way. We got 2 more to do yet. So graph C, we have on the temperatures, what's on the vertical. And on the horizontal is our time. So it went up like this, then it remained constant, then it went like this, right? So, you know what, matching is the easy part. What about when we have to draw them, right? We have to be able to draw them also. We're going to be doing that in your homework. So, anybody have any questions about number 1 here? Okay, then we're going to move on. We're going to do check it out problem number 2 on page 165. So now I want you to put that we're moving into page 165. And the first one we're going to do is 2A. 2A. We're going to be sketching graphs. The other part of our learning goal. I can graph a relationship. Okay? So in this one, it talks about Jamie's taking an 8-week keyboarding class. At the end of each week, she takes a test to find the number of words she can type per minute. And then it says she improves each week. Well, the first thing that we need to do is we need to decide what should be represented on our horizontal axis and what should be represented on our vertical axis. Okay? So it's kind of like, we always put on the horizontal axis what's kind of like controlling the situation. So do you think, like we did when we were talking about rates back in chapter 1, when we talk about, does it make more sense to say, well, after this many weeks, this is how many words she can type? Or does it make more sense to say, this is how many words she can type, and that controls the weeks? Is it practicing?
Go up and then words go.
Actually, the weeks are going to go this way.
Okay.
They're going to kind of be in control, okay? They're going to be in control in this situation. So the weeks are going to be what we have on our horizontal axis, and the other thing that's happening in this is words per minute. So we have to label these so that not only us, but anybody else who looks at our graph can see, as you move across the graph, what's happening, as you move up and down the graph, what's happening. So she's taking an 8-week keyboarding class. I want you to look up at the top of the page, page 165. Look at the type of graph that they have there.
The dot.
It's dots, isn't it? Yeah. That's called a discrete graph. Do you think this one might be a discrete situation? In other words, 1 week, and then this is how many words per minute she can type? 2 weeks, this is how many words? Yeah, this is what we call one of those discrete graphs. And it says she's taking an 8-week keyboarding class, so that means we need how many dots? 8. At the end of each week, she takes a test to find the number of words she can type per minute. So when we're putting them, deciding how high they go, we're deciding how many words she can type per minute. She improves each week. So let's do this much at least, so we have something to guide us here. 1, 2, 3, 4, 5, 6, 7, 8 weeks. Well, we're going to assume that when she tests herself after the end of week 1, that she can type more than 0 words per minute. So we don't even care how many it is, but we're going to say, well, she types some words per minute, right? And she's going to steadily, or she's going to improve. It doesn't say steadily. It says she's going to improve each week. So that means when you're making the rest of your points now, each week those need to do what? Go up, go down, stay the same, go up, don't they? So now we'll just say, okay, well, after the 2nd week, I'm going to assume that she can type a little bit better. After the 3rd week, even a little bit better than that. After the 4th week, even a little bit better than that. And she's just getting, amazing here. But she's improving every time. And we don't have to worry about if they line up in a line. We just have to make sure that they're going up, don't we? Every week, her test score goes up. So Jamie's taking this class for 8 weeks. Kind of sounds like you guys, in what grade was that? You guys had to do that 7th grade? Keyboarding? Yeah. And then did you have to take some tests to see how well you did? How many words per minute you could type? Yeah. Okay. Back when I was in school, it was a typewriter. You ever seen those?
Yeah.
Yeah. Okay. And then it says, not only should we sketch it, but tell whether it's continuous or discrete. Well, we already made that decision because it helped us make the graph. It's what kind again? Discrete. So we're going to write that here. It is a discrete graph. Discrete meaning there's no in-betweens going on. So she's not testing every, like random times between the weeks. She's taking the class at the end of week 1, she's taking a test and getting a score. End of week 2, taking the test, getting a score. Okay, anybody have any questions on that?
No.
Okay, let's go to 2B then. Our last one that we're going to do here. 2B. Henry begins to drain a water tank by opening a valve. Then he opens another valve. Then he closes the first valve. He leaves the second valve open until the tank is empty. So first of all, we got to decide, do you think this is continuous or discrete? What's happening here? Because what we got is time going on with water coming out. So would this be discrete or continuous?
Discrete.
Does he open the valve and close it right away? Open it again, close it. Does he open it, close it? No, he opens it, lets it run out. Then all of a sudden he opens the second valve and there's more water running out. 2. He doesn't, and then eventually he closes 1. This is really a continuous graph. This would be what we call a continuous one. So we need to then decide, okay, continuous means we're not going to have points. We're going to do like what's happening back in checkout number 1, where we're connecting the pieces. So we got to decide what's going to be on our x-axis, our horizontal, and what's going to be on our vertical axis, our y-axis. So I would say time is kind of controlling things here. How long the water is draining out. I know the valves part, you want to kind of include that, but that's going to decide how fast and the water's coming out. And then water level is actually going to be what's going to be represented on the y-axis, because it says he drains the tank. So we need to know where's the water level at a given time. Okay, so begins to drain a tank, water tank, by opening a valve. What do you think is going to happen then? So opens a valve. What's going to happen to the water level? Going up or going down? It's draining.
Down.
It's going down. It's draining. So he opens a valve. Do you think that water's going to come out at a steady pace?
No.
Well, what would keep it from coming out at a steady pace?
Turn it up like all the way.
Okay, but if he just opens it, is it going to come out at the same rate? Yeah. So we would say opens a valve. It looks like it should come down something like that to begin with, right? Water's coming down. And then it says, then he opens another valve. Opens another valve. So now there's 2 valves open. Water is draining out. Maisie, what's going to happen? What would that look like? Could you put your foot down? It would go down? Same pace? Same rate? Should it be the same so we could just extend this line longer? You guys agree? Could we just extend this so the line's going to go longer because it's going to come out at the same rate? Is it going to come out faster now or slower? Okay. Okay, we open a valve. We don't mess with that one. We just let it keep draining. All this, apparently this tank has 2 valves on it. We open another one. Should the water come out faster now? Yeah, there's more water draining out at a time. It's coming out of 2 different valves. So now it should be coming out faster. So now it's still coming out. Our water level is still going down, but it's going down at a faster rate. It has to be steeper because the water level is going down at a faster rate now. Then he closes the first valve. Closes, let's just say 1, it doesn't matter which one. Closes 1. He leaves the second valve open until the tank is empty. So he's closing this first valve and leaves the tank open until it's empty. So he's closed one of them. So now what's happening? It's coming out again slower because the water level is going down at a slower pace. So now, when he closes that one, we could basically say it's going back to the same way it was coming out in the beginning, isn't it? And the fact that it's until the tank is empty means it better come all the way down to 0, right? So let's start this. The water level's up here somewhere. There's our first part. Opens a valve. Opens another valve. Remember, that one's going steeper now because the water is going out faster. The water level's coming down quicker. And then he closes one and leaves it open until it's empty. So now it's going to. This is how you make good decisions about making your own graphs. I'm not going to let you just be like, put some pencil marks down and call it good. Not gonna happen, okay? You gotta show me you understand. Any questions? Okay, let's go to work on homework then.